Welcome to this Instructable, how to make a custom shaped PCB, star-shaped PCB with Inkscape and EasyEDA. So here's the final PCB design and showing a quick screen grab of the EasyEDA web-based PCB designer. So here we can design the schematics and the PCB in the tool, and you can see it shows all the 3D components as well, and we can see exactly what that board's going to look like. So this Instructable will talk through exactly how we built this. Here we're going to use EasyEDA, and we're going to create a new project. We'll put a name on that project. We'll call it the star. And this is an Instructable. Check out the Instructable website linked in the comments. So now we have our project. We start off with the schematic. We can do a quick save on that, and that will appear in the project, sheet 1. We can also add a PCB. So we just right click on the project, click new PCB. The defaults here are fine. Give a 2-layer copper PCB, which is 100 mils by 100 mils or 10 by 10 centimeters. Now here we're going to import a DXF, which is the outline of the board. This is what we created in Inkscape. So let's just go find that file. So here's the outline file. And the important thing here is to check that we've got the layer set to board outline. Click import, and the pink color here matches the board outline. Now this is going to replace the rectangular one. So we left click that, right click to complete, click the rectangle that was there as the default, delete that, and here's our new board outline, which is the pink color there. Now we also want to put some graphics on. So the silk layer, so we have a separate file there, top silk layer. That's going to draw some stars and graphics on top, which will help us place the components. Again, set the layer here to top silk layer, so that'll appear on the right layer. There we go. So yellow color is the top silk layer. I'm trying to line that up right over the board outline so it's nicely aligned. I need to zoom in a little bit just to make sure that's really accurate. What we're going to do is just select that board outline, and we'll just move that to make sure it's aligned up. So we'll just turn off that top silk layer just so we can see, okay, what have we selected here? Actually, we need to select the whole outline. Let's turn the top layer, silk layer back on so we can see what we're doing, and then just move that board outline so it's aligned. So there we go. So now you can't see the pink, it's actually hidden underneath the yellow color here of that top silk layer. We'll save that. We can look at the photo view just to see, okay, well, what does this look like? And you can see, here you go. The white lines show the silk screen, and the outline of the board, all working great. The 3D view is pretty cool as well. That kind of really helps us kind of just see, okay, what's this board look like if we spin it around? Okay, great. So there we go. That's a really simple way of creating a custom shaped PCB from importing that DXF. Now we can also place some components. So here in the spreadsheet at the bottom, this is a list of the bill of materials. And this is from the LCSC part list, which is from the JLC PCB library, which they use for assembly. So we put in the LCSC number, click on that, we can see the shape of that in terms of the footprint that will be on the PCB, and we can also see, you know, a picture there of what that component looks like. So we'll place that in. This is the ATmega 328P, which is often used inside of Arduino Nanos and Unos and so on. So quite a commonly used 8-bit MCU. We also want to place some of those other components in there. So for example, what's this one? Surface mount capacitor. So that's a 10 microfarad capacitor. We'll place that in as well. That's going to be a decoupling capacitor. If we push the space bar, we can rotate and put it the right way around. Left click puts in place, right click stops placing components. So that's the 10 microfarad capacitor. Let's now put in the 220 microfarad capacitor, nanofarad capacitor. That's the other decoupling capacitor. So we'll select that, Control C to copy, paste component, double click, Control V to paste, search for that, and then we can click paste. Now you can see here I made a mistake. I've pasted another 10 microfarad capacitor. Maybe I didn't quite hit the right button there. We'll come back and fix that later. Let's place the LED. So place component, put that part number in, hit search, click on the LED. That's the important thing. That's the step I missed last time. We'll place that, we'll put that at the top. There we go. And let's see what else we need. We need a resistor as well, series resistor. So let's select that component. We'll place that, actually we'll paste it in, hit the search, click on that, and then click place. So we can place that component up here. Good. So next what we need to put in, okay. Let's have a look. So we've got a few components there. Now's maybe some time to do some wiring up. We'll hit this wiring tool, or W as the keyboard shortcut. And oh look, these capacitors, maybe these are the wrong way around. I'm going to put the plus symbol at the top. Oh look, I've just noticed the 10 microfarads, the wrong capacitor there. So let's take that, 220 nanofarad, place the component, paste it in, do a search, hit place, and there we go. Oh, still the wrong component. How did I do that? Try again. There we go. Search, click that, wait for it to load, place. Good, there we go. There's the capacitor. Spacebar to rotate, and we're going to rotate that C1 as well. Put the plus at the top. Good stuff. There we go. So there's our capacitors. Let's do some wiring now. So we'll connect up VCC on top of those. Connect that to the VCC pins on the MCU. There we go. Connect up the ground pins as well. So we can just click where we want to put the corners. Click, click. There we go. And connect. Click again. Click, and then connect. There we go. We can add a ground to that, and we'll add a VCC as well. Where is it? There we go. So that's the VCC and the ground for the board as well. We've got some extra ground and VCC pins there to connect, so we'll just wire those in. Good. Right, there we go. Now we can move around with the middle mouse button, so we can drag that around. We can also connect the other ground pin there, and we might want to connect the other VCC. So that's the analog VCC pin, but we can connect that to the same VCC. There we go. Just move these wires around. Let's grab that VCC. Okay, we'll stretch the wire a bit first. Grab the VCC connector. There we go. So that's the power connected up. Now, what about those LEDs? So we want to have two LEDs on this board. We'll have one on the top side and one on the underside for each of the LEDs. There's going to be a total of 10 LEDs spread around the design on each side of the board. So 10 on the top, 10 on the bottom. So that's the signal coming in through the series resistor into the LED, and then LED to ground. Now here's the magic bit. At the top here we can save, and we will convert it to PCB. So the button at the top here, update PCB. We'll skip the DRC checks, but what happens is now all these components will get added to the PCB. First they'll get shown down the bottom right hand corner, just off the side of the board, and it's as simple as dragging and dropping them to where we want to put them. You see these lines that are lit up? That shows you kind of the connections that we're going to need to make, like VCC ground for those capacitors. And we can push space to rotate these. So I've got the pin 1 on the top left corner. I'm going to put the capacitors over near pins, I think it's 4 and 5. So the decoupling caps are nice and close to those power pins. There we go. I can push spacebar to rotate, make them the right orientation. Now the LEDs I'm going to want to put at the top here. So LED 1 on the top side, LED 2 on the back, and the resistor is going to go where that little rectangular mark is. So again, move them around, spacebar to rotate. Let's get it the direction I want. So the signal comes in the bottom from the resistor. I'm going to place that resistor just over that box there. So those boxes I put there just to kind of place out where the resistors are going to go. The stars show where the LEDs are going to go. Now LED 2 I want to put onto the bottom layer. So I did a drop down there, change the layer, and you can see it's a different color. It's actually sitting underneath LED 1. There we go, just move the labels around to make it a bit more readable, so not conflicting with the other markings on the PCB. There we go. Let's get that better aligned. That's all in the right place now. Good. Now we might want to start wiring this up. So we're going to connect up LED 1 to the resistor. There we go. And you saw those blue lines, the blue line that was showing, hey, we need to make a connection. That's now done. We might want to move these capacitors around as well, put them a bit close to the pins there. And we can wire those guys up as well. Move those labels so they're not crashing into the and conflicting with the other things on the board. Tie that up a little bit. There we go. And then we can push W or push that wiring symbol there, and we'll connect these pins up. And you see by default it has some clever routing. It'll use the 45-degree angles to make it neat. There we go. That's all connected. And right click when we finish connecting. Great. So some ground pins need to be connected up. We'll connect those later with a ground plane. Let's hit save. Let's have a look at what it looks like using that 3D viewer again. And you can see here actually it's smart enough to actually put 3D components already on the board. So it seems the libraries have been updated all the time. We've used those LCSC parts and they've got 3D models associated with them, so we can see how it looks. There we go, this is the top side. So there's LED 1, resistor 1 and LED 2 on the back as well. Just where we said it would be. Pretty neat. So we can use the mouse buttons to spin that around, move it around. So that's good. So now we're going to need to connect the signal pin down to the microcontroller itself. Now I didn't actually make a connection on the schematic. So one thing I wanted to do is just kind of see, okay, actually let's work out what pins it's going to connect to. Let's keep it neat by actually looking at the physical layout on the board and seeing where the pins land. So let's connect this into pin 27 on the microcontroller. So it's giving me a warning here because that's, there's not a connection on the schematic. That doesn't add up on the schematic. But we can make that connection. It's probably not the best way to do it. It's probably better to do it on the schematic. I should probably connect that on the schematic first. You see it's renamed that pin now R1_1. So that was the resistor 1 pin. So we can change the name of that. We could call it U27. U127, which was the previous name there, and we could change the net name to match that. There we go, so that's now matching kind of that pin name on the MCU. And let's hit save, let's look back at the schematic and let's make that same connection. So we had pin 27, there we go. So we want to make these two things match, so we'll draw a wire out from pin 27, and instead of connecting all the way to the top, actually we can use the net labels. So if we look in the wiring tools up here, the little N symbol, net label, we can put any name on that we like. So we could call that LED 1, for example. So we'll just double click on that, change the name. There we go. We want the same label up on the pin at the top. You see it tries to be clever and sequentially sets the numbering. Here we can set them both to LED 1. Let's hit save on that. We'll click update PCB. Let's skip those DRCs again. It says, hey look, we've changed some of those net names. So it's kind of taken those net name changes, and interestingly what it's done is now labeled that net LED 1. So that connects up through to LED 1. Okay, so that's now connected, which is great. We're just going to add a ground plane now. So we click on that kind of dotted line, draw a box around the whole design, right click when we're finished with the shape, and as if by magic it fills in that whole ground plane. So this was net ground GND. On the right hand side here we can choose a couple of options. Actually first we need to just select, and then we can say solid or grid, for example, if we want a different field, or no solid. It's quite useful to switch back to no solid when we're doing some more routing, and then we change it back to solid again later. So again, let's take a quick look on the photo viewer, and we can see, hey look, it's connected up all the ground pins for us. So the ground on the resistor, the ground on the MCUs, all those ground pins are now connected automatically for us with the ground plane. So that saves some wiring up, and it looks kind of neat as well. So we'll hit save on that. All right, what's next? So now we're going to put some more LEDs on the board. Let's copy these LEDs and paste them. And you can see again, it's automatically renamed all of those components. So R1's now R2. LED 3 and 4 would change those names as well. Actually thinking about it, to reduce some confusion, we can have, so LED 3 and 4 on the right hand side here. And I'm just going to rejig these around a little bit. So actually I want 2 LEDs at the top, on the top layer, 2 underneath of course. Thinking about the numbering again, actually it might be simpler if this was LED 1A and LED 1B. So B for the bottom side LED, because they're connected to the same signal. So this is now really LED 2. So we'll call this one LED 2 instead of LED 4, and we'll call this one LED 2B to go underneath. So we can make these changes. It might cause a bit of confusion when we do the update PCB. So you can see it's added those components, we've changed some net names. We've got these new LEDs that go onto the bottom. Yeah, so the LED 2, it's actually kept it in the same place, even though it's not the same connection. It's kept it into the same place. So we can play with this. Let's change the ground plane back to no fill, so we can just see what we're doing in terms of the routing. We're going to put LED 1B up there. LED 2B is going to go underneath the star there. Let's turn the top layer off, jump down to the bottom layer. Let's just move that component back down to the right place. There we go. And 2B is going to go here. So it's going to go underneath. Actually, we've got these on the wrong side, haven't we? So R2 is going to come up here. So we need to make sure we've got these components in the right places. So I want to rotate this guy. So 270-degree rotation. We just type that in. And like I say, we could just use the space bar as well to rotate by 90 degrees at a time. Cool, so we just place that neatly over there. Let's see what LEDs we've got here. So I think we've crashed those two into each other. So let's have a look. So I'm just going to turn the snapping off so it helps us to, there we go. So we've got LED 2B on the top and LED 2 on the bottom. Actually, we want it the other way around. So let's see. Just move those labels. And let's fix the layers on those guys. So how do we swap these around? I'm going to put 2B, that needs to be on the bottom layer. There we go. And the other guy needs to be on the top layer. There we go. That's better. And this one's on the bottom layer. And spacebar to rotate that guy around. There we go. And we can drop it underneath. And we'll drop this one underneath as well. Move those labels, make them a bit more readable. And you can change this text size later. You can make the text size a bit smaller. You can even move the text away or delete it altogether. If you know exactly where the components go, you just want to really simplify minimize the clutter on the board. Wire these guys up. So we're connecting up on the top layer now, the resistor signal up to the LED. I'll turn the snap back on. So a nice simple connection there, job done. So it's looking a bit odd. It looks like the bottom layer LED is kind of looking like it's on top there. I guess it's just the way it draws it. Now we haven't yet connected the LEDs underneath the board. We'll do that a little bit later on. Now let's think about the signal here. So this R2, actually, let's just bring this straight down to pin 28. Now this time we'll make the change in the schematic viewer first. So LED 2 is going to connect to pin 28. So we'll draw a net out from pin 28. We will add a net label here. We'll call that LED 2. So it matches the connection we have up here on the left. Good. So that will now connect to that pair of LEDs, LED 2 and LED 2B. Hit save. We will go back and hit update PCB. Where's it gone? There it is. So you can see it's just changed some net names, apply changes. You can see now we've got the blue line there, the rat lines, to connect that up. So now we're connected to the LED. So we haven't connected underneath yet. So let's now kind of go and do the underneath connections. So to do that, we'll put some wires in place. So there's a tool up here, see the button called Via. There we go, we'll just click on that and we can place that via somewhere nearby. So for example, we could actually, if you click on a net, when you place the via, it will automatically label or set the net name for that via. So I'm just gonna, I clicked on the pad there, it's made it ground. So we've got the ground plane on the top, but we're going to connect underneath. So the via will go down to the bottom layer. Oops, I just connected that with the bottom silk. That's why it's called green. I should have picked bottom layer, the blue layer instead. Where's it gone? It's up near the top there. There we go. Bottom layer in blue, connect that through. There we go, good. So now we've got the ground connection to the LED on the underside, so it can connect through from the via on the top. Great. We also need to connect the signal through underneath. So I'll bring a wire down from the LED pad, place a via there. That will automatically get connected to LED 1_1. If we then go back to the top layer, again that's connecting through to the routing we already had there to LED 1_1, which is the wire from the resistor. Good. So we've now connected those signals through on the top side and the bottom side. Of course, you can run the DRC checks. It will tell you if there's any missing connections. We know we haven't connected this other LED yet, so let's just do the same thing here. Let's get a via, place it on the signal line there. We can drop through to the bottom layer. There we go. Select the wire, connect it up. Good. And we'll do the same on the ground. So draw a wire up and right click, and then we'll place a via on top of that net. There we go, there's a ground via, so I'll connect up through as well. Good. So those two LEDs, or 4 LEDs, 2 on the top, 2 on the bottom, are now all connected. So we can now, let's refill in the ground plane. And you can see, interestingly, it hasn't managed to fill in the middle there. I couldn't find a path to connect the ground through. If we just move that track over to the right a little bit, then the ground will fill through neatly. So let's go refill that. There we go. I'll hit save. And we'll have a 3D view again. See how it's come out. So you can see all our, actually this is the photo view, 2D view. So you can see the connections coming up. Ground planes are all good. We've got the vias in there as well. So we've got those signals through to the back side. We can also look at the bottom side of the board. Again, you can see those vias and connections connecting up to the LEDs as well. Good. Now we should also look to add some graphics on the back, put the same kind of star patterns on the back, so it doesn't look quite so plain and bland on the back. There's the 3D view. Yeah, the backside looks quite empty, but we can fix that. So here we're going to do an import DXF again. We will import that silk screen and put it on the bottom silk layer. Hit import. Let's just zoom in, line it up perfectly with the top layer. Good. Right click. So we did a left click to place it, right click to stop placing. There we go. I've got a silk screen on the bottom. So we'll have a nice design on the top and bottom. And we can go and edit that later if we want kind of less of the symbols or more of the symbols. We can change all that around. Alright, so there's a whole load of LEDs, and it could be that we want to paste obviously some more LEDs into the board for another arm of the LED. We'll call this LED 3 and LED 4. Of course, change the names of the LEDs there as well. Actually, these were LED 4s out there, okay. We'll make some LED 3. I'm just going to swap those around. So there's 3 on the outside, 4 in the middle. Good. Hit save. We'll update the PCB. And you can see it's detected those changes. So those new components will sit off on the edge of the board. And so then we can go ahead and place those on the board in the right places. So we use the same methodology. I'm not sure what happened to that. Must have moved it by accident. We'll go put that back in the right place. That's the ground plane. We'll make that no fill for now, so we can see what we're doing. Now at this point, we're going to rotate these LEDs so they're rotated to kind of match the alignment of the arm on the star. A little bit of trial and error here. I mean, you could just use the rotate tool. Now, each arm technically is kind of 72 degrees apart. We can try and put 72 in, push the space bar, rotate. That's not quite right. Sometimes kind of 36, which is half of 72 works. Or sometimes we need 18 degrees, which again is half of that. Or I guess it's 72 minus 18. So we can move this around. Sometimes just trying kind of the negative number like minus 18 or minus 72 can help as well. There we go. So 18 degrees. That's where we should have started at 18. So that gives us the right rotation. That aligns nicely with the star. We will turn the snap off. That helps us just place it a bit more centrally. Move that label out of the way. Same angle for the bottom LED, so we can try and put the 18 degrees in there. Now we know it's 18. There we go. Hit rotate a couple of times so it's the same orientation. There we go. That's all neatly placed as well. And do the same with the resistor. So 18 degrees for that one. Actually, that wants to sit on top of the box. We'll just move that over. There we go. And same for the other LEDs. So now we know the angle. It's going to be a bit quicker this time. 18 degrees. Put it in the right place. Want this board to look nice. Now we can actually edit the footprints as well. So there's quite a big kind of bounding yellow boxes around these footprints. We could edit the footprints and delete that, make that simpler. Maybe just leave the pads and that kind of central marker that talks about the orientation. There we go. LEDs placed. And there's the resistor. There we go. So, LEDs on the board, neatly rotated. Let's have a quick look at what that looks like. It's looking pretty good. No, we haven't put the... There we go, bottom side LEDs on the other side there. So the bottom's kind of like a mirror. Great. So, Hit save. Now here we can check what nets are connected, not connected to the. Click on the Design Manager, click on the nets. That tells us what connections are not made. And you can see as you click on these, you can see the connections. Now remember early on we connected that net up and we renamed the net. We connected it before we connected the schematic. And that's caused a bit of confusion there. So we're just going to fix that. That's LED 1 we changed that pin to, so that should fix that. We'll just click the little arrow there, redo or recheck. It's all okay. So LED 3 is not connected yet, so let's just go route that. Now the routing angle by default, like I say, is 45 degrees. Let's just change that to free angle. And we can use any angle of Y we like. So we can connect from the resistor to the LED. Good. And similarly on the other side, resistor to LED. There we go. That's the two LEDs connected to the resistors now. Now the ground and VCC net's not connected. They'll be connected by the ground planes. Now this LED 4, let's see where that's going to land. We could connect that into pin 23, I think. So we click on that net again. We can move that around. There we go. We'll have like a horizontal line connecting into pin 23. Now let's go back to the schematic. And we will draw a net out from here. So push W, we'll push that symbol. Let's do a wire out. We'll add a net label. This is going to be LED 3. Or is it LED 4? Save that. Update PCB. Make these new connections. There we go. So that pin's now called LED 4. So we can draw a wire out of there. And there we go. So that's now connected. If you look at the net list on the top left, the Design Manager, it's all happy. All the connections have been made. Good. So that shows you just how we can kind of rotate components, make them look a bit neater, connect them all up. You can see I've done some of the routing as well, kind of on the same kind of freeform angles, just trying to kind of align out with the shape of the PCB. So we've got 2 arms done, a few more to do, but you guys can go do that. Here's the full schematic. This is what I did a few months back, so it looks a little bit different, like the shape of that 80 mega in the center is a bit different. When I first started this, I didn't use those LCSC parts straight off. I've got some different pads on here. There's some buttons, push buttons, some spare signals I've kind of routed out to separate pads. There's a USB connector for power. It doesn't connect the data pins. It gives you a nice easy way to power it up. There's a 60 megahertz resonator there for clocking. There's a programming header. We have, and you can see I've kind of drawn a dotted line around to show the shape of the PCB. If we zoom in on the PCB, here's all the LEDs connected up and all placed. As I mentioned, you've got those pads on the right hand side here, giving us the spare signals, some of the analog inputs we're not using. Here's some of the LEDs. There you go, there's those pins, so there's a spare kind of D7, D8 we're not using, and some of the analog pins as well. So we've done some star-shaped pads, so we just did again a DXF import to import shape, and we put it on the metal layer, right clicked it, changed it to pads. If I take away the fill, ground plane fill, it just makes it a little bit easier to see all the connections we've got on the board. So there you go, programming headers on there now, the buttons are in there. We'll go refill that and have a look at the 3D view as well. So there's all the components laid out. Pretty neat. This 3D view is pretty cool, but it just shows you what it's going to look like when you've got that PCB. So for the majority of these surface mount components, the resistors, the LEDs, the MCU, we can get those built onto the PCB for a fairly low cost. They're all fairly standard parts. We'll show that a bit later on. So to actually go order this board, we can use this generate Gerber. Make sure we save it first, of course. So yeah, we see generate fabrication file, so the Gerber file. Normally check the DRCs, check there's no errors here, but I'm just going to here we go, so we can kind of check. Now there's one little issue with this particular footprint for this USB connector. It's saying that kind of a couple of those holes are a bit too close to the pads, gives an error, but we're gonna risk it. I think there's probably a better footprint we could use for this particular component. We export the BOM, so when we ask for the assembly, we'll need that list of components. So we save the BOM file. We'll also export the pick and place file. So that tells the assembly line where to place those components, what rotation and so on. But then to actually get the board ordered, we need to use that generate fabrication file. And it gives you a quick preview there. So 5 PCBs from $5 because it sits within that 10 by 10 centimeter size limit. So we can jump straight to the web page and you can see how that looks. We can choose different options. Now if you want assembly, unfortunately it's only available in green right now, but there are, if you're doing your own assembly, you can pick all those different colors. The defaults are all fine here. Normally it puts an order number on there. I've put a text box saying JLC PCB, JLC, 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 which will get replaced by the order number. So I want that in the right place. Let's turn on the assembly. I'm actually going to go with the top side assembly. That's where the majority of the components are. So I'll have to manually solder those LEDs on the underside, but it's just a few components there. 10 PCBs. So that'll cost about £10 for those PCBs. And here's where we can add in the bill of materials. And we can also add in the pick and place files as well. So there you go. So I won't show you all the steps, but here you can see it kind of shows you, where those components would be placed on the board, on the PCB. You can check rotations and so on. This is actually just a snapshot of that second design. You check the LEDs the right way around, check the MCUs the right way around, check the capacitors the right way around because they've all got polarity. It looks like the LEDs are the wrong way around. The plus symbols are on the outside, whereas they really should be on the inside. So we just need to look at it a bit more closely and make sure things work as you'd expect. And that's it. I hope you enjoyed the project.